Hello everyone. Good afternoon to all guys. Am I audible to everyone? My voice is clear to everyone. Let's respond in the chat box, everyone. Okay. Everything is good? Okay. So today we are going to start or going to discuss the last paper questions. Okay. So in the last, yesterday you have attended this test, na AIT test papers discussions. Today it will be happening in your class. Okay. So let's discuss from the first questions here. Simple question, you have to evaluate this limit when limit extending to 1 minus, and in the numerator you have root pi minus on root of 2 sine inverse of x upon root of 1 minus x. Clear? So let's solve. What is the answer? Sure. Check. Solution is actually, first check, is it in the form of 0 by 0 or not? Yes. Why? Sine inverse of 1. Sine inverse of 1. How can you check? Root pi minus on root of 2 sine inverse of 1 upon 1 minus, that is, so we know sine inverse of 1 is pi by 2 and 2 into pi by 2 becomes pi. So root pi minus root pi is 0. So it is in the 0 by 0 form. Okay. So when we have 0 by 0 form, we can apply the L'Hopital rule. So what is L'Hopital rule? L'Hopital rule क्या होता है? That is, you need to differentiate the numerator and also to the denominator until yet we are not getting some finite value after putting the limit. Okay, so let's check. First, start differentiating the numerator. If I'll differentiate the numerator, the differentiation of root pi is 0 minus differentiation upon root of 2 sine inverse of x is actually minus 1 by 2 root of 2 sine inverse of x, and 2 sine inverse of x is actually 2 upon root of 1 minus x square. Okay, so this will be 1 minus x square upon differentiation of 1 on root of 1 minus x is 1 upon 2 1 minus x, and differentiation of minus x is minus 1. Okay, now if we'll simplify this, but you will get, that is minus 2 or 2 to here cancel out. So this will be minus 1 upon 2 sine root of 2 sine inverse of x into root of 1 minus x square into, that is minus minus to cancel हो जाएगा ना. 2 into 2 into root of 1 minus x plus 1. So this will be यहाँ से this will be cancelled out and you will be having 1 plus x. This will be 1 upon root of 2 sine inverse of x into 1 plus x, right? Now if you put the limit extending to 1 minus in 1 upon root of 2 sine inverse of x into 1 plus x, it will be 1 by 2 sine inverse of x is pi by 2, that is pi by 2, and this will be 1 plus 1. So finally answer is root pi into root 2. So in the numerator, we have 2 again. Let's check. This is the answer or anything else? Yes, in the numerator also we have 2, na? So this will be 2. 2. So the answer is 2 by pi. This is your answer. The first question. Okay. And root of 2 by pi is your answer. Is that clear to everyone? Okay. Shall I move to the next question? Okay. So move to the next question. Question is, how many of you attended this question? The question is, if f of x is equal to x square minus 4 into x cube minus 6x square plus 11x minus 6 plus x upon 1 plus mod x. Okay. So then the set of points at which the function f of x is not differentiable is. So you need to find the points of where the given function is non-differentiable. And we know, suppose you have a function, there is a concept, okay? Suppose you have a function f of x is equal to g of x plus h of x. And if I'll say at some points, g of x is not differentiable. Okay, so at some point, g of x is not differentiable. And also at some point, h of x is not differentiable. Then in general, we can say f of x is not differentiable at these points and also is not differentiable at these points. So on those points, g of x and h of x are not differentiable. At those points also, f of x is not differentiable. Is that clear to everyone? Yes, clear? Okay. So let's start observing the given question. What is that? The question is given that f of x is equal to x square minus 4 into mod of x cube minus 6x square plus 11x minus 6 plus x upon 1 plus mod x, right? Okay. So if we'll take this function as my g of x, I'm taking this as g of x. Okay, suppose I'm taking g of x is as x upon 1 plus mod x, right? So is it continuous? Is it continuous everywhere? Yes, it is continuous. Because why it is continuous? Because at all points of the domain of this function, the graph is not broken. Okay, if you draw the graph, it will not be broken. Okay, so that's why it is continuous also. Clear? Is there any point where my function will not be defined? No, there is no points where my function will not be defined. So that's why this function is also continuous, because mod x is always positive. Na? Mod x is always positive. That's why denominator is always positive. It can't be 0. If it is 0, then it will not be defined. But it can't be 0. Na? So that's why this function is continuous. If this function is continuous, and also another thing I'm saying, if I'll take g of minus x, so what will happen? minus x upon 1 plus mod of minus x. This becomes again minus of x upon 1 plus mod x, which in place of these functions, can I write minus of g of x? Yes. So here we are getting the property, it is satisfying g of minus x is equal to minus of g of x, right? That means g of x is then, hence we can say g of x is an odd function. Is an odd function. So what I'm saying, it is a continuous function, also it is an odd function. Okay, so that means this function is differentiable everywhere. Okay, this function is differentiable everywhere. How? Fellas say, see, for x is greater than 0 also, f is g of x is differentiable. And for x is less than 0 also, g of x is differentiable. How? You can feel this. Let's draw the graph. Let's draw the graph of this function. Okay, check. Draw the graph. Sure. Okay. So x upon 1 plus mod x. That means the maximum value will be 1, right? Maximum value will be 2 or 1. So maximum value will be 1 and minimum value will be minus 1. Yes, yes. Maximum value will be 1 and minimum value will be minus 1. So suppose this is the line of y is equal to 1, and this is the line of y is equal to minus 1. Minus 1. So when x is greater than 0, it will be increasing. Yes or no? For x is greater than 0, this function x upon 1 plus mod x will be increasing or not? Yes or no? Right? But when x is less than 0, it will be decreasing. For x is less than greater than 0, the graph of the function will be like this. And the maximum value is 1. Okay. And the minimum value will be like this. Okay, is that clear? So this is the graph of the given function, sorry, g of x, and you can observe here this graph is continuous everywhere. Is there no points? There is no points where the graph of the function is broken. Clear, everyone? Okay, sure. Let's observe the first function also. We have discussed about this last function. Then now we'll discuss about the next function, which is also given that, suppose I'm taking this function as h of x, which is x square minus 4 into mod of x cube minus 6x square plus 11x minus 6 mod of this. Okay, so if we'll factorize or split the terms of all these expressions, it will be x plus 2 into x minus 2 into mod of, it will be x minus 1 into x minus 2 into x minus 3. If you try to split, you will get this. Suppose I am taking this function was f1x and this function as f2x. Now try to draw the graph of this function. Okay, now try to draw the graph of this function. Okay, so for the first f1x, if I'll try to draw the first function f1x, that is the roots are minus 2, 2. The roots are minus 2, 2. Suppose this is my -2 and this is my 2, right? So then the graph of this will be a parabola because this is a quadratic expression. This is a quadratic expression. So the graph will be like this. Okay, the graph will be like this. Then come to the second thing, that is x minus 1, x minus 2, x minus 3. The roots are 1, 2, 3. This point is 1, 2, and 3. Now if you'll start from 3, if you'll take any number greater than 4 and we'll put in this expression x minus 1 into x minus 2 into x minus 3, it will give you a positive value. The start from positive side, like we start from positive side and come to the point 3 here, and in between 2 to 3, if you'll take any value, it will give you what? 2 to 3. It will give you negative value. 2 to 3. Positive or negative? 2 to 3. Suppose I am choosing 2.5. 2.5, that is, it will be negative, it will be negative, it will be 2.5. No, positive. It will be giving you positive value. And at point 2, just check, wait. Sorry. Don't go through that actually. So when we are reaching to the point 3, then the any cubic graph will be like this. If you draw the graph, it will be like this. Yes or no? Now, because we have mod, then we need to take all the negative portion to the positive portion. That means this graph will be taken offside because we have more. Okay, we have more. And here also we need to take this to offside. The graph will be like this. And we are getting only 2 points. Those are the sharp points. We are getting only 2 points. Those are the sharp points. So we need to erase these graphs. Okay. So those are the 2 only points where we are getting sharp points. Those points are 1 point is 1 and another point is 3. The yellowish point are my sharp points, and we know at the sharp points function is not differentiable. It is everywhere function is differentiable everywhere. This function is differentiable everywhere, but f2x, here we are getting f2x has 2 sharp points. Sharp point means at those points we can draw a lot of tangents, infinite number of tangents where the slope is not defined, right? So those points are called sharp points, and f2 has those 2 sharp points. Those are 1 and 3. So f2x is not differentiable at the point x is equal to 1 and 3. Similarly, at all other points, my f of x is differentiable, but only we can say, only come to the first portion, only we can say this is the function where it is differentiable everywhere. This is differentiable everywhere, but this is are not differentiable at the point 1, 3. So the answer is option D is the correct answer. So f of x is not differentiable at 1, 3. So answer is option D. The correct option is D. Is that clear to everyone? Yes. Shall I move to the next question? Chalo. Clear? So graphically we can solve these questions. So you need to draw the graph properly actually. Then you can solve this type of questions easily. Right? Sure. Let's move to the next question. What is that? We have. So f of x is equal to 2x cube plus 9x square plus lambda x plus 20 is decreasing function of x in the largest possible interval -2 -1. That means when we are going from -2 to -1, the function is decreasing, right? The function is decreasing, but we need to find the value of function at -1. That will be the largest possible decreasing function. That will be the largest possible interval. Then you need to find the value of lambda actually. Yes, you need to find the value of lambda. It's simple. Okay, let's solve. Chalo. So if we'll solve these questions, f of x is given as 2x cube plus 9x square plus lambda x plus 20. Okay. So we know it is given that the function is decreasing. That means my first derivative must be less than 0. Yes or no? Yes. So try to find first derivative of the given function. That is 6x square plus 18x plus lambda, which is less than 0. So let's forget about it and equate with 0. If we'll equate with 0, then it will be, if we'll try to make it perfect square. So what will happen? X square plus 9x, x square plus 3x, no, sorry. X square plus 3x plus 9 by 4, 3 by 2, okay? 9 by 4 minus okay, so that is 2 into 3 by 2. Yes, 3 by 2. So 3 square by 2 square. Also 6 is multiplied here, no? So we have previously nothing. So 6 is 27 by 2. Okay. So subtract 27 by 2 plus lambda is equal to 0. Now make x in x plus 3 by 2 square minus 27 by 2 plus lambda equal to 0. That is, so it will become x at x is equal to -1. If you put it x is equal to -1, this becomes -1 plus 3 by 2 square minus 27 by 2 plus lambda is equal to 0. Then this becomes 6 into -2 plus 1 by 2 square, that is 1 by 4 minus 27 by 2 plus lambda is equal to 0. Then lambda is equal to, this becomes 3, 2. So this becomes 2, 3 minus 24, 7 plus 7. That is lambda becomes 24 minus 24 by 2, that is minus 12. So lambda becomes minus 12. Yes, is it? Is it minus 12? I think it should be 12. Let's check. 6, just a minute. Let me check again. So 3 by 2 minus 27 by 2, that is 3 minus 27 plus 12, no? Yes, sorry. So lambda becomes 12. Okay, so what is the correct answer? Option A is correct. Guys, option A is correct. Okay, everyone. Sure. Let's move to the next question. I hope this is clear to everyone. If you have any doubt, you can ask. Okay. Let's move to the next question here. It will be also taking time to solve this question. You must understand the question first, what he is asking. So f of x is given that 2 minus mod of x square plus 5x plus 6. When x is not equal to minus 2, but when x is equal to 2, the function gives you a square plus 1, right? A square plus 1. Sure. ठीक. The given function is there. That is f of x is equal to, when x is not equal to minus 2, function becomes x square 2 minus x square plus 5x plus 6. Okay, so just I'm taking first y as x square plus 5x plus 6, and just I'm trying to factorize it. I'm getting x plus 3 into x plus 2. So try to draw the graph of this. So what will happen? What type of parabola you will get? This point is minus 2, this point, sorry, minus 3, and this point is minus 2. Then you will get like this parabola. Yes or no? Okay. So when we'll take the mod, then the graph changes to minus 3, minus 2. Then the graph changes to this type, because the negative portions becomes positive. Okay. And when we'll take minus with this, when we'll take minus with this, then the graph changes to, how the graph will be look like? Minus changes to minus 3, minus 2, then the graph will be like this. And when we'll add to these functions, suppose I'm doing here now, y is equal to 2 minus mod of x square minus 5x, sorry, plus 5x plus 6. This is the function, no? Yes. So when we'll be adding 2 positive to the given function, then the graph will be goes to 2 units downwards or upwards. When we are adding, the graph will be shifting upwards to 2 units. That means suppose this point is minus 3 and this point is minus 2, then and this point is 2, y is equal to 2, then the graph will shifting 2 units upwards. That means the graph should be like this. Okay. The graph will be like this. When I'm adding 2 units, then when we will add, then the graph will be shifting upwards now. You know, from the transformation of graphs, you already have studied, I hope. Okay, so this is the graph of this. Now this is the graph of this. Now come to the original graph. Now we'll try to make the full graph. Suppose Okay, sure. So now, sorry for the interruption. Actually, I was facing some technical problem. Okay, suppose this is the line of y is equal to -2. Y is equal to, okay, this is -3, this is -2, origin 2, right? So it is given that when x is a, when, see, in the question it is given that when x is equal to 2, it gives you a square plus 1, right? And here now the graph is actually like this, and at x is equal to -2 you have to give a hollow circle, because at x is equal to -2 it is not defined for the first condition, when x is not equal to -2. Okay, this is the graph. Now at x is equal to -2 we know that is a square plus 2. Yes, sorry, a square plus 1, a square plus 1, right? And which is greater than equal to 2, because in the question it is given that already. But it is given that the range of a, so that f of x is maximum at x is equal to -2. At x is equal to -2, f of x must be maximum. Then you need to find the range of a. The maximum means, so graph must be, to be maximum, it must be greater than equal to 2. Yes or no? Then here we are getting an inequality. So a square plus 1 is greater than equal to 2. We'll solve it. A square is greater than equal to 1, and which we can write mod a is greater than equal to 1. So this is our answer actually. Mod a is greater than equal to 1. So see in the which option we have mod a is greater than equal to 1. Option A is the correct one. Option A is the correct option. I hope this is clear to everyone. You need to understand all the graphs first. You know? You need to understand how we can transform the graph. Transformation of graph is important. Just go through the there is a book, Aryan book, that name is Play with Graphs. You know? From there also, and from any standard books also, these graphs are given. How we can draw the graph of any complicated functions. Okay, so no, I'm not saying to draw the graph of every function in or existed in the world. No, it is not possible by not through the programming. Okay, so now I hope this is clear to everyone, guys. This is clear to everyone. Okay, so let's move to the next question. Here we have one differential equation. It is given that let y is equal to, just a minute, guys. Let y is equal to y of x be the solution of the differential equation. Then it is given that dy by dx is equal to y plus 1 into y plus 1 into e raised to x square minus x square by 2 minus x, when x is lying between 0 and 2.1. With the initial condition y of 2 is equal to 0, then you need to find dy by dx at x is equal to 1. Right? So let's solve. So what is the equation given? That is dy by dx is equal to y plus 1 into y plus 1 into e raised to x square by 2 minus x. Okay, this is the equation given. So to solve this equation, let's put y plus 1 is equal to t. So this gives you dy by dt is equal, sorry, dy by dx is equal to dt upon dx. So just substitute this in the given equation. Try to reduce it into linear differential equation, then you can solve it. Okay. So if you substitute it, this becomes dt by dx is equal to t into e raised to x square by 2 minus x. Okay. Sure. No. So this becomes dt by dx is equal to t square e raised to x square by 2 minus dx. Okay. Now, if I'll ask you to let again put, no, let's divide 1 by divide t square on both sides. Okay. Divide both sides. So what we will get? We'll get 1 by t square dt upon dx is equal to e raised to x square by 2 minus x upon t. So finally, if you'll put here 1 upon t, sorry, I'm taking minus 1 upon t as, okay. Okay, then if you differentiate it, it becomes 1 upon t square into dt by dx is equal to dk by dx. Okay, dk by dx. Now in this place we can substitute dk by dx minus kx. This becomes minus kx. Kx, okay, minus kx. Minus kx, and if you take this to this plus, and then k in place of k, if you put in place of 1 by t, if you get minus k, then it becomes again minus, then kx is equal to e raised to x square by 2. Now you can see here, this is a differential equation which is in the form of linear differential equation. Now how we can solve it? Use the integrating factor first. So integrating factor becomes e raised to minus x dx, integration of minus x dx, that is e raised to minus x square by 2, right? E raised to minus x square by 2. Is that clear to everyone? If this becomes e raised to minus x square by 2, then my solution, general solution will be y, k into integrating factor, that is e raised to minus x square by 2, integration of q, that is e raised to x square by 2 into e raised to minus x square by 2 dx plus c. So the right hand side and the left hand side becomes, in place of k we can directly substitute, in place of k we can substitute here minus 1 by t, and in place of t we can substitute here y plus 1, and in place of y, okay, so minus 1 upon y plus 1 minus 1 upon y plus 1 is equal to, this becomes e raised to minus x square by 2, this becomes x plus c, right? So x plus c, so if we'll write this as minus 1 upon y plus 1 is equal to x plus c into, we take this e raised to minus x square by 2 to right side, it becomes e raised to x square by 2, right? So it becomes e raised to x square by 2. Then if you simplify it, if you put y is equal, y of, we have given in the question, y of 0 is equal to, y of 2 is equal to 0. If you take x as 2, just take x as 2, and then y was 0, minus 1 upon 0 plus 1. And in place of x, just put 2 plus c into e raised to 2 square, that is 4, 4 by 2 is e square, right? So finally, what we are getting, minus 1 is equal to 2 plus c into e square, right? So from here, by solving, we are getting c is equal to minus 1 upon e square minus 2. So value of c we are getting here 1 upon minus 1 upon c square minus 2. Now we need to put this value of c in the above equation, and then we'll differentiate the given function. So we know y plus 1 is equal to minus 1 upon x plus c into e to the power x square by 2. From this we can write. From this we can write. Yes. Okay. So if we'll write this, so in place of c, just I'm putting minus 1 upon x minus 1 upon e square minus 2 into e raised to x square by 2. So if we'll differentiate this function on both sides, we'll get dy by dx is equal to minus e raised to 3 by 2 upon 1 plus e square whole square. This is the answer actually at x is equal to 1. And if we'll solve or simplify, we'll get e raised to, that is, answer is e raised to, first option, minus e raised to, option A is the correct one. Minus e raised to 3 by 2 upon e square plus 1 whole square. This is the answer actually. I hope this is clear to everyone. We are solving the most lengthiest questions in this exam. Okay. We are not going through the easy questions. So first questions are very lengthy questions. It has been came in your exam. So these questions you can see. This is a lengthy question. It's not lengthy, but it will take time to think about it. Suddenly you can't. If you did not solve such type of questions, then you can't able to solve the questions at the moment, right, in the examinations. Okay, this question also, this is actually easy question, but the first question also, the first and the second question also, they're difficult. Okay, so let's move to the next question. I hope the differential equation wala question is correct, understood to everyone, guys. Let's move to the next question here. Okay. It's actually, this is the question, you can solve it easily. So let's solve it. Okay. So what is the question? Let f of x and g of x be two functions satisfying these conditions. Then you have to find the value of integration from minus 4 to 4 f of x square dx. And this is the question from definite integrations. Okay. So it is given that in the question, just see, f of x square plus g into 4 minus x is equal to minus 4x cubed. Okay, so I'm writing this as, I'm taking this 4x cubed to the left hand side, I'm writing the equation of this. And what I'm doing, I'm integrating from 0 to 4 to each of the term. 0 to 4 f of x square dx plus 0 to 4 g of 4 minus x dx minus the integration 0 to 4 4x cubed dx is equal to 0, right? Okay, so if we'll integrate it, see, 0 to 4 f of x square dx and 0 to 4 g of 4 minus x. We know one property. What is that? Since we can write here, since we know integration 0 to a f of x dx is equal to integration 0 to a f of a minus x dx. If we use this property in the middle term, of the above integration. So what you will get? We'll get 0 to 4 f of x square dx plus 0 to 4 g of 4 minus x, that is 0 minus 4 minus 4 minus x, that is g of x. Okay, g of x dx minus 0 to 4 4x square dx, right? Okay, and this is equal to 0. Huh? We have 0 in the right hand side. Okay, chalo. Okay, and we have in the question also g of x is equal to g of x is equal to g of g of x. Can we write g of x as just a minute? Okay, no. Okay, if you'll give this equation as equation 1 and this equation and equation 2, if you'll add these two equations, what you will get? Adding 1 and 2, we get क्या मिलेगा भाई मुझे बोलो? So if you'll add these two equations, we'll get 2 into 0 to 4 f of x square dx, and this becomes 0 to 4 g of x dx. Oh, sorry. Directly we can write g of x plus g of 4 minus x dx plus minus 2 into 0 to 4 4x cube dx, right? And in the question it is given that g of x plus g of 4 minus x is 0. That means this integral becomes 0. This integral becomes 0. So what do we have finally? We are having 2 into 0 to 4 f of x square dx minus 2 into 0 to 4 4x cube dx is equal to 0. Clear? Okay. So from now here we can write 2 को cancel कर सकते हैं. If we'll take these two right hand sides, we can write 0 to 4 f of x square dx is equal to 0 to 4 4x cube dx, right? If we'll integrate it, we'll get 4 into x to the power 4 by 4 0 to 4, and we'll get finally 256. Okay, so right hand side becomes 256, right? Right hand side becomes 256, and we know one property, guys. We know one property. What is that? Minus a to a f of x dx, and if f of x is an even function, then we can write 2 into 0 to a f of x dx. If you use this property here, okay, if you use this property here, what you will get? We'll get, we can write this as 0 to 4 f of x square dx. Yes, 0 to, it is given that, let me check, 0 to 4 f of x square dx, this becomes, okay, so we can write this as 2 into, by using this property, 2 into 0 to 4 f of x square dx, that is, we know this as 2 into 256, and this becomes 256 into 2 is 512. So 512 is the correct answer. So 512 is your correct answer. So option B is the correct one. 512. Clear, everyone? Sure. If you have any doubt, you can ask. Let's move to the next question. What is that? Oh, it's from 3D. Chalo, let's read your vector. Okay, let's solve this one. The length of the perpendicular from the origin to the plane passing through the point vector point A and containing the line R vector is equal to B plus lambda C vector. Okay. Oh, let's solve. The length of the perpendicular from the origin to the plane. You need to find the length of the perpendicular from the plane to the from the origin to the plane, right? So if you draw the plane first, suppose this is my plane and this is my normal to the plane, n vector. Okay, and it is passing through a point A. Suppose it is passing through a point A here. Okay, and also containing the line R is equal to B plus lambda C. So, कोई दिक्कत नहीं. Containing the line R is equal to B plus lambda C. That means it is passing through the point B, passing through the point B and parallel to the vector C. Yes or no? Am I correct or not? Yes. Sure. So if we'll join these 2 points, A and point B. Okay. So, and thus you need to find the length of the perpendicular from the origin to the plane. Okay. Suppose here I'm taking the origin. This point is my origin. Suppose I'm taking O and the position vector O, origin is O vector. Okay, and if we'll join this point to A, O vector, and if we'll draw a perpendicular from the origin along the normal vector, okay, along the normal vector, and this distance is D. Okay, so you need to find this vector D. You need to find the D. Okay, so this is the understanding of the given questions. You need to find the D. Okay, so let's start solving the questions. It is given that my L is R vector is equal to B plus lambda C. Okay, and AB becomes AB. Suppose this point is A and this point is B. So AB becomes B minus A. If you write position vector wise, and N vector becomes, that is N vector, AB cross C vector, AB cross C vector, because the direction of the line R is C vector. So AB vector direction, normal vector will be AB vector cross C vector. That is, when you will take cross product of 2 vectors on a plane, then the resultant vector will be giving you the normal vector to the given plane, and it will be representing to the normal, to the direction of that plane, right? So this becomes AB is actually B minus A cross C. Is that clear? Let OA vector is equal to A vector. And we know cos alpha. Suppose alpha is the angle between the alpha is the angle between the vector OA and the normal vector. That is also equal to this. The vector OA and the normal vector. Then the cos alpha will be what will happen? The OA dot n vector upon magnitude of OA into magnitude of n vector. Is that clear? Then the perpendicular distance D will be the projection of the length of the perpendicular from the origin to the plane passing through the point A. Okay, so OA, the projection of OA along the normal vector, the perpendicular distance will be the projection of the vector OA along the normal vector, right? This will be D. This is my projection of OA along normal vector. If you understood all these concepts, then you can understand these concepts. Okay, here we are taking the projection of the vector OA along the normal vector. That means this distance, this length we are getting. Is that clear? Next, so this becomes distance D becomes OA vector, projection of OA along normal, that is OA vector, magnitude of OA into cos alpha. And we know what is cos alpha? No? OA into OA vector dot n vector upon OA vector to magnitude into n vector to magnitude, that is here cancel out. Then we are having OA vector dot n vector upon magnitude of n vector, that is OA vector is A vector dot B minus C vector cross C vector upon magnitude of normal vector, that is B vector minus A vector cross C vector. If we'll rearrange these things, what we'll get? We'll get A dot B cross C minus C cross, A cross C. Yes, then the denominator becomes B cross C minus A cross C, and this is the modulus. Okay, now so if you take the dot product in the numerator, that means this becomes A dot B cross C minus A dot A cross C. So this becomes, when we are taking the dot product of same vectors, then this becomes 0 upon magnitude of B vector cross C vector minus A vector cross C vector. So totally finally we are having A dot B cross C, that is box product of ABC. You can write box product of ABC upon, this is actually same as mod of B cross C minus A cross C. Okay, magnitude, right? So simply if we'll change the direction of the vectors ABC, box product of ABC upon B vector cross C vector, if we'll change the directions, that means if we'll rotate C to A to C, then this will be plus A vector cross C vector of magnitude. So this is the answer. So which is the correct answer? Let's check the question. Box product of ABC upon B cross C plus C cross A. Option C is the correct one. I hope this is clear to everyone, guys. It's time to end your class. Thanks for your patience. Thanks for your time. Take care. Bye bye. Good night.